A body is said to be in motion if its position changes with respect to surrounding, and it is said to be at rest if its position is not changing with respect to surrounding. Hello students, welcome to my next online class. So in this video I am going to explain the projectile motion and circular motion. So projectile means here whenever any object is thrown with some initial velocity and it covers few distance without being propelled by any fuel and falls down due to action of gravity. So we can say the path followed by a projectile is called trajectory. For example, this is a horizontal line, that means ground, and at the position of A you are standing and you are throwing an object with some initial velocity u. So when you are throwing an object with an initial velocity u, that velocity is being resolved into two components, that is u sin theta in vertical direction and u cos theta in horizontal direction. So when an object is being thrown with some initial velocity u, this object acquires or attains maximum height at point B and then falls down due to Earth's gravity. So the path followed by this projectile, this path is called trajectory, right? So when an object is thrown from horizontal at an angle theta except 90, then the path followed by it is called projectile and the object is called trajectory, and the object is called projectile, and its motion is called projectile motion. Now it is not mandatory then object has to be thrown from an horizontal direction only. So suppose this is a building and when you are standing here and when you are throwing an object, the object will fall like this. This path is also called trajectory, okay, and the object thrown is called here projectile. So there are few terms based on this projectile motion, that is horizontal component is u cos theta, vertical component is u sin theta. So when I say horizontal component, that is u cos theta and vertical component is u sin theta. And throughout the journey u cos theta remains same, okay, because velocity along horizontal direction does not changes as the acceleration is 0 there, okay, as acceleration is 0 means you can say velocity along horizontal direction is 0, so therefore horizontal component, that is u cos theta, remains same, and vertical component, that is u sin theta, decreases gradually and becomes 0 at highest point of the path. Like when an object is thrown like this, this is the maximum height attained by that projectile, and at this point vertical component is 0. So at maximum height vertical component, that is u sin theta, is 0 here. At highest point the velocity of the body is u cos theta in horizontal direction and the angle between the velocity and acceleration is 90 degree there. So important formulas for projectile motion. So at highest point what is the linear momentum, that is mu cos theta, and kinetic energy is given by half mv square. So half m is there, v means here u cos theta square, right? The horizontal displacement, that is x u cos theta t, and vertical displacement is u sin theta t minus half gt square. So actually from where we got this one, you see, we know s equals to ut plus half a t square, right? Now when it is horizontal component, our s is x, right, equals to u means horizontal velocity, that is horizontal component u cos theta, t as it is, plus half at square. A means here, I just now I said that in horizontal direction acceleration is 0, so 0 into half into t square, that is 0. So therefore this gets omitted, right? So only we have ut, that is u cos theta t. So in horizontal direction you have u cos theta t. Now in vertical direction again s equals to ut plus half gt square. Now in place of u we have u sin theta t. Now g is minus g because object is thrown in upward direction, and gt as it is, right? So you see this is equation number 1, that is x equals to u cos theta. This is equation number 1 and this is equation number 2. Now if you substitute equation number 1 as t equals to x by u cos theta, if you write u cos theta and substitute here in this equation, in place of t we will write x by u cos theta, then we will get this equation x tan theta minus g by 2 u square cos square theta x square. So this is an equation of the trajectory path, right? So it is similar to the equation of parabola, okay, like y equals to constant x square. Okay, so there are different forms of parabola. Parabola, when I say, there can be upward parabola, there can be downward parabola, right? So this is a parabola, this is a right-handed parabola, left-handed parabola, upward parabola, downward parabola, and left parabola, okay, left-handed parabola. So these are the curves of parabola, shapes of parabola. So here this equation matches with the equation of parabola, so we say that the path followed by a projectile is also called parabolic path. So the path of the projectile is parabolic because it follows the trajectory of parabolic. So these are the different formulas, you can say. If I say what is the kinetic energy at the lowest point, that is half mu square. What is the linear momentum at the lowest point, that is mu. So similarly this one I will be giving in note in PDF. This all you need to write in your exercise book. The maximum height occurs when the projectile covers a horizontal distance equal to half of the horizontal range. That is, if an object is thrown, if the total distance is r, now at half of the distance it acquires maximum height, that is r by 2. Okay, so when an object is thrown, the time taken to reach the highest point is called time of ascent, and the time taken to fall from maximum height to the ground, that is called time of descent. So total time of flight is given by 2t, t plus t, that is small 2 small t, that is capital T equals to 2 small t. So it is the time or total time for which the projectile remains in air. So this much time is required by a projectile before touching the ground. From a horizontal direction, if you are throwing any object, it will take some time. From here, just now I told it is t, and from here it is t, time of ascent and time of descent, right? So therefore capital T, that is time of flight, equals to 2t, where t is given by u sin theta by g. Okay, so this is the total time of flight. Maximum height, it is the maximum vertical distance covered by the projectile, that is given by h equals to u square sin square theta by 2g. Horizontal range is given by r equals to u square sin 2 theta by g, that is the maximum distance covered in the horizontal distance. Okay, This is called horizontal range. Okay, from starting point to the final end. Horizontal range is maximum when it is thrown at the angle of 45 degrees. So whenever you are throwing any object, and if that velocity is making 45 degree with the horizontal, then it will cover maximum distance. And for an angle of projection and 90 degree minus theta, the horizontal range is same, that is 90 degree minus theta. Okay, if this is theta, this angle is 90 minus theta. Now what happens when any object is projected horizontally? Now you are at a certain height, and from here you are throwing any object. The object has to fall due to Earth's gravity. Now on its path at a particular point, there is horizontal velocity as well as there is vertical velocity, right? So horizontal velocity u remains same and vertical velocity gradually decreases, right? First here it increases, then at a certain point after striking the ground it decreases. So similarly we have time of flight. Now formula gets changed. Time of flight t equals to root under 2h by g. Horizontal range, that is u root under 2h by g, and vertical velocity, that is gt or vy equals to gt. And the total velocity when an object is falling from a certain height at this particular point, it has horizontal component also, it has vertical component also. So the net velocity by which it falls on the ground is given by root under v square plus y square. Okay, vx square plus vy square. Vx means u square and vy means gt square. This is the formula. Okay, so this is the net velocity by which an object strikes the ground when it is thrown from a certain height. And the angle phi from the horizontal is given by tan phi equals to vy by vx. That means when an object is thrown here, this is the net velocity, and if this is vy and this is vx, right, and you are calculating here phi, that means if this is vy, this is also vy, so tan theta equals to perpendicular by base, that means vy by vx. This phi you are calculating, that is tan phi equals to vy by vx. Vy means gt and vx means u. Equation of projectile when it is thrown from a certain height, that is y equals to minus g by 2u square x square. So these are the few formulas for which, now when an object strikes the ground and it is thrown from a certain height, again that is given by vx square equals to vy square. So substituting the value of vx and vy here, we will get this equation. So when an object is moving in a circular path is called circular motion, and the movement in a circular path can be uniform, can be non-uniform. If the magnitude of the velocity of the particle in the circular remains constant, then we call it as uniform circular motion. Now if the magnitude of velocity of the body in a circular motion is not constant, okay, then it is called non-uniform circular motion. Angular displacement is given by del theta equals to del s by r, where del s is the linear displacement and r is the radius in radian. Angular velocity, it is given by omega, that is given by del theta by del t. So this all you need to write in your exercise book and remember the formulas. So in a circular motion, an acceleration acts on a body whose direction is always towards the center of the path. This acceleration is called centripetal acceleration. When an object is in a circular motion, the force acting towards the center is called centripetal force, and the acceleration acquired by an object moving in a circular path at its center is called centripetal acceleration. That is, in circular motion, acceleration acts on the body whose direction is always towards the center of the path. This acceleration is called centripetal acceleration. And centripetal acceleration is also called radial acceleration, whose unit is meter per second square. And it is given by v square by r, or it is given by r omega square. And centripetal force means force which is acting in a outward direction. That is, it is directed along the radius of the circle towards its center. That is a centripetal. Now we will come to centrifugal, that is force which is acting in the outward direction. So this is an expression for centripetal force, that is F equals to mv square by r, or mr omega square. Right? So the force which acts in the outward direction is given by centrifugal force, right? Now in centripetal force we have tension in a string. Okay, so many other examples that comes under centripetal force, like when an object is being rotated in a circular direction by tying with a string, the force on that string gives the centripetal force. That is, tension in the string is equals to the centripetal force, that is given by mv square by r, and centripetal acceleration is given by av square by r. So in this video only this much, so you need to write this in your exercise book and prepare very well. So in my next class we will solve few numerical questions based upon projectile. Thank you.